Hi, this is Professor J.M.A. Chen at California State University, Long Beach. In this video lesson today, we'll look at rational exponents and radicals. Mainly, we want to answer the following question. What is nth root of a? Well, it turns out it depends. It depends on n is even or odd. Before we proceed with different cases, let's recall a few basic properties of exponentials and radicals. The first property says that if I have any number, a raised to the power m over n. What it really means is taking the nth root of a raised to the mth power, or you can think of it as the nth root of a, then the whole thing raised to the mth power. This is because we can write this fraction m over n different ways. We can think of it as 1 over n and then the whole thing raised to the mth power, and that is why we can think of it this way. Or we can think of it as a to the m and then the whole thing raised to the 1 over nth power. This is a natural correspondence to this other expression of the nth root. For example, if I wanted to calculate 5 raised to the 3/2 power, I can think of it as just really taking the square root of 5 raised to the 3. Occasionally, you might want to simplify this expression by realizing that 5 to the 3 is really just 5 squared times a 5. And you can also split this into a square root of a 5 squared times a square root of 5. And this first portion here reduces down to simply just 5. So I get 5 times square root of 5. Second property we'll review here is take any number raised to the negative nth power. It's really the same as saying 1 over a to the nth power. In a way, you can think of this negative sign really turns into this fraction, kind of making that subtraction longer. For example, if I ask you to compute 2 to the negative 3, well, that's really the same thing as 1 over 2 to the positive 3, and that is equal to 1 over 8. Third property is that if you take any number raised to the power a, and then take the entire thing raised to the power b, that's the same as taking the original number x and raised to the a times b. For example, I have 8 raised to the negative 1/3, then I'll first use the property number 2 to turn it into 1 over 8 raised to the 1/3. Then I'll realize that 8 really is 2 to the 3. I can rewrite the whole thing as 1 over 2 to the 3 and then raised to the 1/3 power. So the 3 here is an a, and the 1/3 there plays the role of b. And by the rule, it basically says that I can just multiply those two numbers. That's 3 times 1/3, which turns into a 1. So this answer is just going to be 1/2. Next property is that when you have a number raised to the power a, and then times the same number raised to a different power b, then because it's really the same base, we can combine the powers by adding them. It just becomes x raised to the a plus b. And notice that it has to be the same base in order for us to combine this way. So for example, I have 2 to the 3 and then times 2 to the 4. Because it's the same base of 2, I can use just a single base and then simply add the powers 3 and 4 together to get 2 to the 7th. If you're ever not sure about your rules, you can always calculate using simple numbers. And this is what I'm trying to do here, is to give you an example of a very, very simple numbers, which allows you to verify quickly whether or not you're using the right rules. Here we have 2 to the 3, which is 8, times 2 to the 4th, which is 16. Multiply those two numbers together is 228. The result of using the rule is 2 to the 7th, which turns out to be 128 as well. So this gives me a quick verification that I'm actually using the right rule. Next rule here is the division rule. We have a number raised to the power a and divided by the same number raised to a different power b. Again, this is the same base. I can write it as a single base, but then subtract the powers. I always use the power on top minus the power on the bottom. For example, if I ask you to calculate 64 over 32 using this rule, I first write 64 as 2 to the 6th power, and I write 32 as 2 to the 5th power, and I notice that both numbers share the same base 2. So I can use a single base 2 and then subtract the power, so 6 minus 5 gives me 1. My answer is 2. Again, you can verify this very quickly that you're using the right rules because I know 64 divided by 32 is 2. There are a lot of other rules out there about exponential functions and radicals, but this next one will be the last one we'll review here. If I have a number x times another number y, the entire thing raised to the power n, then I can think of this as each of those two numbers raised to the power n and then multiply. So I have x to the n times y to the n. So notice that I actually have a different base, but both raised to the same power here. For example, if I ask you to calculate 12 squared, it might not be as obvious what 12 squared is. Although this is one of the things we have to remember in the multiplication table, 12 squared is 144. I know that answer in the back of my mind, but let's do this using this rule. I can split 12 into 3 and 4. By the rule, it says that I can take 3 raised to the power 2 and then times 4 raised to the power 2. This becomes 9 times 16. This might be easier to multiply because you have a single digit number and the 2-digit number. So this turns out to be 144 as well. Now we're ready to answer the question, what is nth root of a? Consider the first case if n is even. Suppose nth root of a is equal to some number b. Then it's equivalent to think of this problem as b raised to the nth power equals a. You can kind of imagine getting that equation simply by taking the nth power both sides. Our task is to figure out what b is if n is even. So we start by asking ourselves the questions, what kind of number would I get if I take any number raised to the even power? I'm 100% sure that when I take a real number and raise it to the eventh power, I would get a non-negative number back. This means that my number a has to be non-negative. No real number raised to the eventh power is negative. Notice that this number a is really what's inside of the nth root. If we're saying that it cannot be any negative number, that means we're only allowed to take the nth root of a non-negative number. Another way to say it, a has to be greater than or equal to 0. For example, if I ask you what is the square root of negative 8, the answer would be a nonsense. It doesn't make sense, because square root is an even root, because that's when n is equal to 2. You can't take an even root of a negative number. So the answer to this is, it doesn't exist. Or another way to think of it is the answer to this should be whatever that number squared equals negative 8. And there is no real number squared will equal to a negative number. That's why there is no solution to that. But on the other hand, you can ask questions such as square root of a 64, because now you have a positive number inside the radicand. You can certainly take a square root of that. And that's just going to be 64 raised to the 1/2's power. And we know that 64 is 8 squared. So when you take that and raise to the 1/2's power, using the rules from before, we simply just get a raised to the first, which is 8. On the other hand, if n is odd, this time if we allow n to be odd, we know that if we have a positive number raised to the odd power, it's going to produce a positive result. If you take a negative number raised to the odd power, it's still going to be a negative result. 0 raised to the odd power is still going to remain 0. In this case, our result a here can be any number, any real number, positive, negative, or 0. It doesn't matter. That means I'm allowed to take the nth root of any real number when n is odd. And like in the situation of n is even, we are only allowed to take the nth root of a positive number. N is odd, we're allowed to take the nth root of any real number. For example, I can ask you, what is the cube root of negative 8? This problem actually has a solution. Because we're asking ourselves the question, what number, when I cube it, give me negative 8? Certainly the answer would be negative 2, because when I take negative 2 and then cube that, it would be negative 2 times itself 3 times, and that is certainly negative 8. Next, I want to make a connection between the nth root of a, whose number x, with the equivalent equation, which is x raised to the n equals a. Let's illustrate this with an example. Let's first consider the case when n is even. We have an equation x to the 4th power is equal to 16. This is really to say that n is 4 here and a is the 16 in our notations here. One way to think about it is ask yourself, what number when you raise to the 4th power would give you back positive 16? It shouldn't be too hard to see that when x is 2, you would get that, because when you take 2 raised to the 4th power, you indeed get 16. And also when x is equal to negative 2, we would get 16 as well, because negative 2 raised to the 4th power is multiplying negative 2 4 times. You would also get a 16 back. So there are actually 2 solutions to this problem. A more systematic way of doing that is if you take the original equation x to the 4th equals 16 and take the 4th root both sides. That is, apply basically the 1 over 4th power both sides. And so the 4th power and the 4th cancel, we just get x equals, and that's 16 raised to the 1/4 power, but that is 2 raised to the 4th power, and then raised to the 1/4. So using the property of the exponentials, we have just 2. Notice that what happened here. I discovered earlier that I really should be getting 2 solutions from this. But how can I simply have 1 solution out of this process? Well, this is because you forgot your negative root as well. Every time we're taking the even root, we need to make sure we have plus and minus solution there. Really, from the beginning, you should have added the plus and the minus root here. This is the first time we're taking the root both sides. Every time I do that, I need to make sure I do plus and minus. So I should get plus or minus here, and also the plus and minus at the end. In conclusion, when we solve the equation x to the n equals a, we expect to get plus and minus solution at the end. On the other hand, we simply just take the nth root of a, in this case it would be the 4th root of 16, I would just get the positive 2 out of that. But what I can say is that whenever I take the nth root of the number a, I get the positive solution for the equation x n equals a. Let's write that conclusion down in a more abstract term. We can say that the nth root of a, when n is even, gives you the positive solution to the equation x to the nth power equals a. And the negative nth root of a would then give the negative solution to the equation x n equals a. On the other hand, let's consider the same type of connection before n is odd. Start with our example of x cubed equals 8. We apply the same strategy as before by doing the opposite of the cubing process, which is taking the cube root both sides. We then on the left hand side get rid of the powers and leaving with simply just x. On the right hand side I would get the cube root of 8. We can think of the answer is whatever number that is, cube it equals 8, and so that number has to be 2. It turns out that x equals 2 is the only real solution to the equation x cubed equals 8. No other number cubed would give you a positive 8. Well, you think, well, on the previous situations we have plus and minus root. Why not do the same thing here? Well, if you actually use x equals the negative 2 here and try to cube that, you actually get a negative 8, which does not satisfy the equation x cubed equals 8. This means that you do not have a negative solution for that. The difference between a even case and odd case is when you take an odd root, you only get a single solution, but in the even root situation, you get 2 solutions, positive and negative. So in like the even case, nth root of a is the only solution to the equation x to the n equals a. In summary, we can only take even root of non-negative number, but we can take odd root of any real number. And there are always plus and minus solutions to the equation x to the nth equals a when n is even. That is, x equals plus or minus nth root of a. But there is only one solution to the equation x n equals a when n is odd, namely nth root of a.